from my own point of view, because I was thinking when I heard the term, I was thinking, well, we're programming C and JavaScript. They also have their keyword of function, and how is that supposed to be different than the regular function of programming? Apparently, the function word in the function programming refers to more like mathematical functions, where those functions they don't have any side effects. They're effect free. And why do we do that? Because actually the ultimate goal of function programming isn't about having more readable code, isn't about having less bugs. The whole point of function programming is about keeping the state away. Because as a developer, when you write a big program, then you realize you have to track the state in your mind. Then the code, it becomes difficult for the code to stick into your head, right? But if your program is somewhat stateless or less stateful, then it is easy for a developer to keep the code in his mind, in his or her mind. In that sense, function programming helps. But of course, it's a little bit counterintuitive because the way we learn program, we learn in imperative way. We learn as statements. We learn as we instruct a computer do this, do this. And when you say function programming, people scare away because it somewhat relates to mathematics. But actually, it's some sort of a technique that is just to get away from the state. Yes. So a pure function is about if you put the same input, you get the same output. Just like the trigonometric sine function, if you give the same input, you always get the same output. But in real world, that's not possible, right? Because in real world, a useful application has to interact with the external world. It has to interact. It has to read something from a user, a web service, a database, or it has to similarly, it has to write something to the outside world. It has to record things to the database. It has to submit messages to web services. So we have to tackle this impurity along with the purity. And one of the techniques function programmers apply is keeping this immutable, in other words, keeping these impure functions in the outside region of the program, in the outer room of your program. Anyway, enough talk. So F# is about, I think it's a useful balance between not going too much theoretical, but it's a very pragmatic language, and it's called functional first because it allows you to use it as a regular imperative way, as well as it allows you to use the language in a functional way. So you can use it both ways, which is a good compromise. And here on my screen, you can see this fable.io/RAPL, this address. You can just go there. And I would recommend whoever is watching this to follow what I do, because it's just like let's just take this as a hands-on experience. I just wanted to see how powerful F# can be. So F#, as you know, is a .NET language originally, but there's a transpiler called Fable, which allows you to transpile code F# to JavaScript. So we'll utilize that so that you can just write F# code just from the browser without any tool being installed. For starters, as usual, we'll start with the print hello world. So we just read printf, and we just hello world here, and then we click to the play button on the left-hand side. Then we can on the bottom we can see the console message, the hello world is printed there. And if we actually hit the code section on the right-hand side, then we can also see the emitted JavaScript code, the corresponding JavaScript code that is associated with our F# code. The good thing about this environment, the Fable environment, it's actually somewhat type safe. So if I hover the printf function, it actually shows me the full signature. And if I make any compilation mistake, such as a typo like that, it warns me that, hey, this is not defined. So that's our entry point. And to do something useful, we also need to read some input. Of course, since this is a browser environment, we don't have any console to read. we could utilize HTML as text boxes, etc. But I'm not going to do that. I'll just utilize maybe something like browser's prompt window. So for starters, let's just try to read an input here. To do so, well, let's just get rid of this link actually. We'll define a function called readLine. So let's just, our goal is to read line. And it is optional, but in this case, I will just give the hint here. So this syntax represents the let is just is used for both functions and function definitions as well as variable definitions. Here I define a function, and this empty braces states that this function does not take any parameter. And what will this equal to? For the time being, I'll just do JS, something called JS native, which is not defined. To make it defined, I'll open a module called Fable cover. Okay. So this line basically says we have a readLine function, which takes nothing, which returns a string, and it's implemented as JS native. But what is JS native? Well, it's just a filler. So it actually, in the Fable world, this means we are not going to execute any real code here. Because the reason is we are actually going to use an API that is provided by the browser. And that API we'll access it by the emit attribute. If you know C#, you're familiar with the attributes. In F#, the attributes decorated this way. And it is basically denotes that whenever this function is executed, what will be the corresponding JavaScript output? And here I'll type in the string, I'll type the prompt API, which is built into the browser, and I'll put 2 empty strings, and that's it, I guess. And let's just read this input and print it to the console. So input will be equal to readLine, and then printf the input again. %a. %a refers to something, well, whatever it is, print all. Just, it's some sort of formatter. For timing, it's not important. Actually, we could just utilize the s itself because this is we know that is a string. So let's just do the right thing. Let's run and see what happens. So in my screen, I can see a browser's pop-up window have appeared. And if I type here, hello, and I hit OK, and I can see whatever I typed is printed out. If I look at the code section, what is the corresponding JavaScript code? As you see, on the left-hand side, we are calling the readLine. On the right-hand side, but we see the prompt, there's no trace of readLine. It's basically, this call has been replaced by Fable to whatever we have defined in the prompt. And this effectively allows us to utilize the browser's API, which is called the prompt, to get the input. What are these things? They are just parameters to prompt. I think the first one, just you can define a title. You can check out the prompt API and enter something here. For example, if I do this, it's not so interesting. That message will appear at the top of the thing. And the second parameter is some sort of default value, which is also not interesting. Okay, it's good. So by using this environment, at least we have an environment that we can read and write something. So in this scenario, we'll write a fictitious application, and it will start boring, but I promise you it will get interesting if you be patient. The thing is, let's say our goal is to read some input and check it against something like a 10, a constant. And then we'll just say if the value is greater than 10, smaller than 10, or equal to 10. So it's pretty boring assignment. Let's say, suppose that our manager has given us. To do so, the first thing we'll define our function, which is another let binding, check against 10. Then this gets an I. Then I'll just use this boring if statement. Did it work? Oh, well, I need to see. Is it working? I suppose you have audio. Does anyone hear me? Okay, great. Sorry for the trouble. Let's just move on where we are. Okay, so we were writing our ultimate boring function. If I equals 10, let's just say greater than 10, then we say it's greater than 10. So in F# there is no explicit return keyword, which I'm lying to you actually in some way, but this is how it is. And then otherwise we return smaller than 10. Of course, if you're careful, you would notice I'm actually introducing a bug here. And the bug is that we are actually not handling the case where it's equal. But we'll see about that. And the next thing we'll do is, well, let's just move this function a bit upwards, maybe here, somewhere here. Okay. And then, well, I'll just move it to here. It's better. And then the next thing I'll do is I'll convert our input to an integer, some integer, equals using the int function. This is built into F#, and it does conversion. It's not casting, it's converting. Because as you would know, casting would not change underlying data type. And obviously, string and an integer are represented very differently in the memory. So we are basically converting it. And the next thing I'll do is I'll pass it to function result, which is check against 10, and I'll just pass this some int. Another interesting aspect to notice is I have not specified any type definition. And just because of this comparison against 10, F# was able to deduce I being an integer. And if I hover the original function, you would see this arrow stating that it's a function that takes an integer and returns a string. It was able to figure out this because the right-hand side of these then statements are strings. And actually, although this looks like a small convenience, if you write complicated programs, trust me, you would see this is an indispensable feature, and it's called type inference. And F# would infer the type from the content as much as possible. There are cases where this is not possible, but anyway. The next thing as we'll do is we'll continue our boring application, and then we will what? We will print result. Okay. And I think we are good. So let's just try and run our program, see what happens. I'll hit 11, and it correctly prints out the output is greater than 10. If I hit something like 5, then I would see the output is smaller than 10, which works great. Of course, it doesn't cover the 10 case. But our application is pretty boring, and I would say, I don't know, it's not flexible enough. So let's do some magic. Here we'll introduce a pipeline operator, where functional operators are more like a pipeline in terms of flows. So I'll delete this one. I'll delete this one either. I'll delete this too. I don't need this either. And I don't need this either. And I don't need this either. I don't need any of these things. I'll just delete these things. And I'll utilize the magical pipe operator, where I think this is every F# developer's favorite operator, which is like this. Suddenly, we don't have any error. Everything looks good. I wonder if it works. Let's just see. 11 works. 5 works. How does this work? Basically, this operator is all about whenever the function before has some sort of output, it passes to the right-hand side. So basically, whatever output comes from the read line, it's passed to the int function, which is converted to an integer. Then the output of that thing, it has been passed to the check against 10. And then the final output again is passed to the printf%s function. This way, we could build functional pipelines. And notice I've get rid of all these annoying intermediate variables, which clutter readability in my opinion. This has great benefits, if you ask me, because I think it clearly denotes what you're doing. I mean, if I look at that, I can clearly understand quickly whatever this is about, as well as it allows me to, it gives me opportunity to hijack and introduce additional pipelines here. I can do something else in between. And the definition of this function is, this operator is pretty simple. So if I were to define this from scratch, unlike C#, F# is very powerful to define your own custom operators. So if I were to define from scratch, this would look like xf fx, I suppose. Yeah. So to prove my case, I'll just make it another custom operator temporarily, and you will see it's the same. It's still working. So this is the definition of this operator. It basically takes a constant and it takes a function, then it applies this value to this function and it returns a result. If you hover these things, you would see the prime A. By default, F# assumes the most possible generic thing. So this prime A means it's even more generic than object. It means it could be any type. We don't have any constraints. And F, you see, it has deduced that it's something that gets a prime A because of the type of X, and it returns something else, which could be anything else. So that's how we define custom operators, and this is how this pipeline operator is defined. It's not so magical, actually, as it looks. Cool. We have finished our project. Then we go to our manager. We are proud. We have a very concise syntax. We say, okay, Mr. Manager, I have finished my program. How do you like it? Then he says, well, he or she, well, you're dumb because you're not checking against 10. What? Oh, yeah, I don't. And actually, before that, I don't like those strings either, he says. First, get rid of these strings and then properly check against 10. Okay, let's do that. So these strings are rather annoying, and we would prefer perhaps something more type safe. To do so, we'll introduce discriminated unions. So we'll just something come up, big or small. Let's just fix the current situation first. Big or small. If you're not familiar with this, you can think of, for the time being, they are some sort of like enums, but they're more powerful than that. They are called discriminated unions, not enums. And there's a reason for that. The key word is union, because their objective is to unify different types under a single type, which we will see. In this case, I get rid of this, and I get rid of this. And then what I do is I introduce another function to convert the string, convert to string. Then I say b, big OS, which is match BOS. Match is like a switch statement in many other languages. If it is big, then we say, well, greater, for example, and then small is equal to small. Okay. And the next thing I'll do, because I have the pipeline, I have this convert to string. Let's just copy paste here. Okay, good. Let's just run it. Hit 11, greater, at 3, yeah, small. I can just say greater than 10 to make it more correct. Smaller than 10. Okay, but there's another problem, so we need to fix the bug. And let's say at this point we have written many tests. So whenever we are met with such a bug, as a developer instinct, I am inclined to go here and add another condition here and add another condition here, and I'm inclined to change this because now we are trying to cover the case where I is equal to 10 and we need to print something like an equal. But let's say in a real application you have written tons of tests here and you're proud your program is valid, and you have just discovered this bug and you don't want to touch these things. Can we implement this feature, or can we fix this bugs? Can we fix this bug without touching any of these? Can we? Apparently we can. So let's do that. The next thing I'll do, I'll introduce big or small or equal. Then I'll introduce our new condition, equal, because then this is the equal case. And what if it is not equal? That case has been defined by this one, small. So this looks, if you're not familiar, this might look confusing, but basically we are saying that there are two cases. One is the equal and the other one is big or small. And this type, this actually encapsulating the other one. And because these identifiers look identical, this looks confusing, but actually this is just like a constructor, so I can write anything here. It's free. I mean, they are all the same. But of course I would like to write something more meaningful, and let's just keep BOS. And remember, the right hand side is a type, so we are unifying the type of big or small with this equal thing, which doesn't have a type by itself. And that's why this is called a discriminated union. It just unifies things. Because as I made this bug, I have forgot about that case, and I'm trying to recover from that case. So that's done. The next thing I'll do, I'll introduce version 2 of these functions, which is, let's check against 10, v2. It gets I. And if I is equal to 10, then what's gonna be? Equal. Otherwise, what's gonna be? Well, we pass I to check first version, and once that returns a result, if you just leave it like that, you will see, I need a big or small or equal, but you're returning a big or small. So I need the final touch, which wraps the result into this one. And now all conditions satisfied. If you're confused, this statement is equal to the following. So basically, let's just show the alternative one. You can use whichever you want, but I'm not keen on using parentheses, especially with F#. But these two lines are identical. Basically, in the above case, we are passing I to this one, and then we are passing to this one. In the latter case, this is more like how we program in our day-to-day programming. We pass I and checking is 10, and that is wrapped into BOS. But I'll just stick to the first case for the time being, because I don't like parentheses at all. So I think this looks good. This looks good, which takes an I integer and returns the case. Similarly, we'll handle the convert to string version 2. Convert to string version 2. And that will follow the same logic, which gets a BOS. Maybe I should say big or whatever. Let's call it BOS. And then I do the match statement again. BOS with. If it is equal, the answer is equal to 10. Otherwise, the answer is what? We'll have a BOS case, and I need to extract the content here, which is the BOS, and then I'll pass to convert string BOS, and done. In F#, there perhaps except this unit, this is called a unit case, the parentheses are always optional. I'm lying again, but anyway, so if I just get rid of this is fine. Actually, the real purpose of parentheses in F# is to group things, because sometimes compiler is not able to figure out there are some sort of ambiguities occasionally. So we utilize parentheses to reduce these ambiguities. Other than that, the parentheses does not contribute to function parameters or other things, etc., etc. Okay. So once we have the version 2s, all we have to do is to introduce version 2s. And what's typo. So the V should be capital. Okay, I have some inconsistency here. So I should make this V2 as well capital. Okay, I think we're good. Let's see if all our effort was worth. So we hit 12, works great. We hit 4, works great. We hit 10, works great. So as you see, I was able to keep my promise. I have recovered from our bug. I fixed our bug without changing the original logic. Although this looks like a very contrived example, actually this is something you should consider how you would program in the real life, rather than directly jumping into the core part and messing with that. Because every time you touch existing code, you are basically jeopardizing your stability of your application. You could introduce your new bugs, and it's scary. And I don't want to be scared. I don't want to touch existing code as much as I could. And basically, by utilizing this wrapping logic, thanks to functional programming statelessness, I was able to solve the problem. Okay, good. So I go to my manager again. I'm proud of myself. I solved it very nicely. When he looks at it, he says, okay, but how are you going to validate the user's input? How do you know the user will give you a real integer? Maybe he will make a typo. He or she will make a typo. They will make a typo. They will add a letter or something that is not convertible to integer. How are you going to tackle that problem? You haven't validated your input. That's what our manager says. And it is right. We didn't. How are we going to tackle that? There's one aspect. Well, the problem is you could easily validate the input logic, right? You could just go wherever you read line, you can wrap this up and then validate. The real question is, what are you going to do if the validation fails? Just think about it. What are we going to do? Well, we'll display an error message, okay? But we have established a pipeline here. How are we going to short circuit? We could throw an exception, but in functional programming, we do not like exceptions. We don't do exceptions unless we are really, really forced to. Of course, in the real world, you're connecting to database, then you could try to connect database, and let's say database isn't there, or you misconfigure it, you will get an exception. That's unavoidable. It's for sure. But those kind of situations are more like infrastructural. They're rather unexpected. And in code, they're exceptional. Here, the possibility of a user's type giving a wrong input is not exceptional. It is expected. It is possible. So we have to guard ourselves against that. To do so, we will utilize a type called result. For the unfamiliar, because this wasn't part of F# until I think F# 4.1, I'll just show how it is implemented in the existing library. So result is very simple. It's either okay or error. Okay, well, I wish. Unfortunately, it's just slightly trickier than that. So it's something like prime k, prime k, prime t, prime k of prime t, and of k, something like that. Well, if you're familiar with C#, this looks like the C# generics. The case is in F# we denote generics by putting a prime beforehand. If you don't do it, It's not going to work. So that's required. These I think these rules are coming from because F# is originally designed based on OCaml, so which is another function programming language. So that's why we have this kind of syntax. Whether you like it up or this is how we have to live. Now, once we have defined, which does exist, there's another function I'd like to introduce to you. That is the map function. So if you're familiar with C# or LINQ or even in JavaScript, we have the array.map, or this in JavaScript, in C# we have the select.select. And all it does is once you have a collection, it transforms that collection from one thing to another, right? So let's see. Suppose that we have a function, let's find a simple function called increment, and all it does is x plus 1. So it increments. But let's say, I mean, this function works. We can just say y is equal to inc5, then this our y will be 6. That's definite. It's for sure. So we just incremented that. Okay? But what if, or let's just, I write it this way, 5, the more fancy way. What if the incoming value is not 5, but it is OK 5? Recall that the result, the OKer states that we have an approved result, and that's OK. This could have been an error as well. And our inc function doesn't work like that, because it expects an integer, and you are giving it a result. So it complains that, hey, you have given me a result of int object, but that doesn't match. One way, of course, as a developer reflex, we could just go here and fix our increment function, but that's not the essence of functional programming. We have written this function. I don't want to touch that, just like I didn't want to touch these things either. So instead, we're going to lift the function. By lifting, what I refer to, if I hover the x, you can see it's a function that takes an integer and returns another integer. It would have been good instead if this function would have taken a result and returned a result. So one way to make this conversion is to use map. So let's say lifted inc, I'll just do this, equals result.map.inc. Okay, so let's see what's the signature. As you see, I think I have achieved my goal by utilizing the map. What map does is it lifts both ends, the input type as well as the output type, and it is now a result of int of obj to result of int of obj. And then I can just use this one. Okay. Well, this is a good thing. And if you're familiar with F#, if you're not familiar with F# or familiar with it, then you would see this ugly value restriction. This happens because it's, as I said, F# is an originally a limited, it's a .NET language, and and being a .NET language exposes some sort of limitations. So what we are going to do is, let's just move this to here for the time being. Okay, then it complains for the same, and then I can just print it out. So we can just utilize this one. I think this should work. Printf %a. Don't worry about that error. It's due to some sort of genericity issue. So if I just play, let's just add another input. So I can see the actually OK 6. So you see, I have been able to utilize my existing inc function in the result world by using this map function. That's what it does. Okay. So once we understand we can utilize result map, all we have to do is what? Well, the first thing you need to do is to get rid of this int function. We need some different version of it which actually returns a result. So in this case, I'm giving the hint explicitly, And what I do is match system in 32, which is try parse. If you're familiar with .NET, you might recognize this API. The only difference is from an F# point of view, in C#, this would return an output. This takes an out parameter as an input, but in F# it returns a tuple. And the first parameter of this tuple is if this conversion has been was successful or not. So if the conversion was successful, then we have the new value. Then I'll just return OK V. Otherwise, it means this conversion has been failed. Then I'll just return invalid input. Okay. This should be an error. Sorry. Yeah. Once I've done that, it's just I need to get rid of this int function and just replace this one. But as soon as I do, then this next function complains, hey, I was expecting an integer and you're giving me a result. What is it going to be? So then we'll just utilize our hack, which we discussed earlier, result.map. Okay, works. Result.map works. Result.map works. Well, doesn't work because of ambiguity. Now it will work. But we also have to handle the error case, right? Result. What happens if there's an error, map error? Let's just print that as well. Okay, good. And still we get this yellow squiggles, and the reason being is that, well, because this still returns a result, which I absolutely don't care, and just ignore it. Okay, I think we are good now. So let's just run. I run it, and then I hit 5. It works. I run it again, I hit 11, works. I run it again, then I hit A, B, C. Well, it works again, you see. We got the error message, and basically our old logic, this result map allowed us to short circuit entire pipeline and allowed us successfully handle the error, which is actually, if you ask me, is great. So one more time, even if we have forgotten anything, we were able to, we have forgotten to do validation, we were able to get away with our without changing anything. So, okay. But we can slightly refactor this thing, and I think we could just utilize something like, because these 3 steps are like more like a middle pipeline of our application. So let's call this some middle pipeline. And here we're going to introduce another function, so another operator, which makes a functional composition. This is similar to what you have seen, this operator. So it's basically composes this function. The flow is like that. The input comes here, goes here, goes here, goes here. The difference is that this doesn't require an input. It's like a mathematical composition. And because I have done that, then I can get rid of all these things. Actually, even all of these things. And I can just utilize middle pipeline. And we are still good. I think this code looks good. So if we run again, then hitting 32, so still we are good. We are good. We go to our manager again. We say that after hard work, I was able to fix the validation problem without touching, and I'm so proud of myself. And our manager looks at our code and says, okay, looks good, but in real life, the input is going to come from a web service, and that will be read asynchronously. And your read line isn't an async one. It's just a synchronous one. So that's not realistic. We need a async version of it. Oh, okay. In this case, what we are going to do. So first, we have to write an async version of this one. We have to introduce that one. So it will be fictitious one in this case. So contrived again. Then in this case, I'll just return an async string. Well, I don't have to type that because it will be inferred. But I'll use this block. And then if you recall earlier, I told you that there is no return keyword in F#, which I lied. Actually, there is. And that is reline. But what does this return mean? And as a concept of functional programming, return refers to something like a lifting. So if you recall, I mentioned about result. So suppose that we have x equals 5, and I'd like to convert it to result. Something I want to wrap it into a result. Then what I would do is I would introduce a return function. Then that would be something like that. Then lifted value would be result.return.5. Again, this just complains about genericity, but I can just suppress it by like that. So this is the concept of return. Return actually, in some way, it means lift a value, not a function, but a value. In this case, our read line returns a string. And by calling a return, we are lifting into the async value. So we are wrapping it. In the real world, we are not going to wrap, because probably the function, the web service function, would be inherently async. So we don't have to type this. But in this case, I'm just doing so. Okay, good. So once I did that, then I'll just replace this one. And we have the same problem again, unfortunately. That is, we have again type incompatibility, and it's the same scenario that we have the result map. So all we need, actually, we already know the solution. We need an async map. Async.map. Unfortunately, it doesn't exist in F# library. I think there are maybe 5 to 10 libraries which implement this from scratch. And what we are going to do is we'll implement our own version for the time being. Let map fxf, is it fx or fx? I'm not sure. And then it should be async. We'll verify that. And then what? We'll let bank v is equal to x, and then return fv. Okay, let's just check if it's correct. No, it's not correct. So it should be like that. Yeah, this is correct. So what map function does is just the way similar to what we have seen in the result case. It lifts a function from both ends. In this case, if given f a to b, it converts the async a to async b. And as you see, the moment I have defined this, the error is gone. Basically, what this does is it extracts, so the x is supposed to be an async a, and then it extracts the inner value, then it applies f to v, then wraps the entire result into an async. So don't worry about this. But this is a typical implementation of async map. And we're just going to do the same. And the same. And the same. Well, we're even lifting this one. Finally, so we have completed our async block, but we need to execute it. If this were a .NET program, then I could just do this, run synchronously, and no compilation error. However, it's not going to work. You see, nothing comes out, no pop-up. And the reason being is actually the Fable runs in the browser environment. We are not on .NET environment. We are on the browser environment. And because of that, browser usually, let's say, we need to stick to an async API. And this has not been implemented because it's tricky or maybe not possible to make asynchronous things run synchronously by blocking the browser as main thread. Instead, what is implemented is this one. Start immediate, which says that execute it, but don't wait for it. Execute the async block and don't wait for it. So if I just run, then I have the result. I hit 11, works great. I hit 1, works great. I hit some arbitrary letters, works great. And this somewhat concludes our program. Although I said this is the absolute beginner's guide, I understand we have touched quite deep parts of F#, but my intention is to demonstrate the power of functional programming so that you would get a motivation against that. Because, well, there are tons of books or a lot of tutorials on describing the syntax, but they don't. I believe they don't give you enough motivation to why would you use it. Many C# developers think that why we even need F#. They just can't understand the motivation. But as you see, it's about building bigger programs from smaller programs, how to compose them. And this is just a small big step. I hope you like it, and I will just conclude the streaming. Thank you for watching, who's there with me. I'll post this video to YouTube, and you can rewatch it again. I'll share the link in Twitter and in the Slack channel. Thank you all. Goodbye.